Now, another thing we can do with these radicals is when we have things being multiplied under a square root, we can split them up or we can squish them together. So if I have a times b under here, I can split it up into two separate ones and handle them separately. Division is the same way. And then the third property that we may make use of at some points, sometimes instead of raising to a power and then taking the root, if it's easier, you are allowed to take the root first and then raise to a power. It's up to you. And sometimes you might want to take the root first just because you don't want to deal with big, ugly numbers. It just depends. So let's use these properties now and learn how to simplify. Some calculators now are really nice because they're designed to do this for you, but in case you don't have one of those, or when you have variables involved, let me show you what to do. Square root of 24. What I need to do is split 24 up into the largest perfect square that I can. Well, I think 4 is the largest one inside 24 as a factor of 24. So I split it up into 4 times 6 using the property we just had up there. And then 4 can be square rooted and brought out, becomes a 2, and my leftover stuff is 6. Next example, let's do cube root of negative 40 x to the 4th. Now, something that I need to say about variables is when you want to take the root of a variable, you have to divide your exponent by that number. In other words, if I wanted to take the square root of x to the 4th, I would divide it by 2. If I want to take the cube root of x to the 4th, I have to divide it by 3. Okay, well if you look at this, I can't divide 4 by 3 evenly. So here's what I'm going to do. First of all, let's split up 40 into the largest perfect cube I can think of. How about negative 8? Does that sound good? Negative 8 times 5 gives you 40. Negative 8 is a perfect cube. It's the largest one inside 40. Now, x to the 4th, I already said that I need to divide my exponent by 3, but I can't divide 4 by 3. So think about x to the 4th. We could rewrite it as x to the 3rd times x using laws of exponents that we did before. So x to the 4th can be split up. We take the extra x, move it off to the side, and now I have some things that I can cube root. So cube root of 8, or cube root of negative 8, I should say, is negative 2. 5, I can't do anything with that, so I skip it. Cube root of x cubed is just x now. And this extra x, I can't do anything with that. So my leftover stuff is just 5x. So you split numbers up into perfect squares or perfect cubes or whatever you're looking for. And you split variables up into powers that can be divided by this number out front, this number that we call the index. So this 3 here is my index for this problem. And if I want to cube root something, I have to make sure that the variables can be, the exponents of those variables can be divided by 3. Let's do one more. Let's just do square root this time. Let's do square root of 200 x to the 5th, y to the 2nd, z to the 7th. Okay? Now it looks really scary, but it's really not. So I take 200, and what's the largest perfect square in 200? Well, I think I could make it 100 times 2. X to the 5th can be x to the 4th times x. Y squared is good the way it is because it's an even number, and I'm trying to divide by 2 when I square root. And z to the 7th, I have z to the 6th, and I take my extra z, move it off to the side. And now I just start at the left, work my way right, and try to square root if I can. So square root of 100 is 10. Whoops, 10. Square root of 2, I can't really do anything with that, so I skip it. X to the 4th becomes x squared. Y squared becomes y. Z to the 6th becomes z cubed. And this z I skip. Now, one other thing I want to mention. You know, we talked before about how if you want to square root a square, You get the absolute value, and I haven't done that here. And the reason is, for this class, I want you to assume that all the variables under these square roots are positive because it makes the problem easier. Now, sometimes they may not be, but I just want to make sure that you're able to simplify square roots. I don't want to throw in that extra crazy stuff. So we are going to assume for this course that all the variables underneath are positive unless I tell you otherwise. If that were not the case, I would need to put absolute value around this. Wouldn't need to put them around that because it's already squared and it'll never be negative anyhow. But I would need absolute value around y. But let's assume that the variables are always positive and then I won't have to do that. Okay, now what's my leftover stuff? Well, I think 2, an x, and a z. Should we do another one? I think we should. Let's do, I said I'd do one more, but I fooled you. We're going to do more than that. So let's do 24 x to the 5th. Okay, another perfect cube, so I split it up, or I'm cube rooting, I should say, so I need to find another perfect cube. So how about 8 times 3? If we've dealt with 24 before. And then x to the 5th, this time becomes x to the 3rd, x squared. 8 comes out, becomes a 2. 3 can't do anything with when I'm cube rooting. X to the 3rd becomes x. Wouldn't need an absolute value here in any case because it's cubed. It's an odd power. And then x squared can't do anything with that x squared. So as weird as it seems, I have an x squared that's still inside. I know you're used to getting that x squared out of there, but can't do it because we're cube rooting, not square rooting. Okay? So hope you enjoyed that. You know, one other thing I want to mention, with this 200 here, if you would have accidentally split that up into 4 times 50, then the 4 would have come out. You would have gotten 2 root 50. And you could have still got the problem right. You would have just had to keep going and do 25 times 2 next. So always be aware that if you don't get the largest perfect square right away, it's no big deal. You just have to do it in 2 steps. Kind of like when you were younger and you tried to reduce fractions. Sometimes you didn't get it reduced all the way the first time and you had to divide top and bottom by something else again. So sometimes if you don't see the biggest number right away, you just do it in 2 steps. Not really a big